Okay, so today is Unit P lesson, or day 4. We're going to go over equations of lines, graphs, and then the applications of that. So first off, slope. We've already talked about this before, but slope is y2 minus y1 over x2 minus x1, and that's where you're given point x1 comma y1 and x2 comma y2. And so if you want to find the slope between those 2 points, you plug it in that formula. Slope-intercept form, then, it's what you've used for quite some time. Mx plus b, where m is the slope, b is the y-intercept. Okay. Now, I don't know how much you've used point slope. Hopefully you've had some experience with it, because this one is, you actually use this a lot in calculus. So when next year you get to calculus, you're going to be using point slope more than anything. It's very useful for the information you're typically given in calculus. And what it is a lot of times point slope means you're given a point, so x1 comma y1, and you're given a slope. Okay, so you're given a point and a slope. So it's y, and that's the same as this y. So that is just a y, minus y1, which is this value. So that's going to be a number. You're going to plug a number in right there. Equals m times x, and this x represents the same thing as that x, minus x1, which is this guy right here. Okay, so that's the x coordinate of the point. And then there's standard form, which, to be honest, isn't very useful on very many occasions, but we still learn it. So it's ax plus by equals c, where this x is the same thing as that x, and this y is the same thing as that y. So the a, b, and the c are going to be numbers or coefficients that you'd fill in. One case with this, if b does equal 0, that means it's a vertical line. So if b equals 0, that means you have a x equals some number, so that's going to be one of those vertical lines. And if a equals 0, horizontal. So if a was 0, it would be a y equals equation, which is a flat line. Now, parallel lines are, two lines are parallel if the slopes are equal and the y-intercept is different. Okay, and we say that you're probably always going by two lines are parallel if the slopes are the same. We do want to have different y-intercepts, because if they have the same slope and the same y-intercept, then they're the same line. So you're not really dealing with two lines that are parallel, you're dealing with the same line. And then, versus perpendicular lines, these are, two lines are perpendicular if the slopes are opposite reciprocals of each other. And that's to say that if one was, the slope was m1, the other one would be 1 over negative m2. The two slopes would be 1 over. So some examples here. We've got Camelot Apartments purchase a $50,000 building. For tax purposes, its value depreciates $20 or $2,000 per year over a 25-year period. It's obviously not very accurate real world-wise, because eventually it's going to be worth nothing. So write a linear equation given the value of y of the building in terms of x. Okay, so y would equal, and it's going to start out with $50,000. That's like my y-intercept, and then I'm going to subtract from that $2,000 for every year that passes, and it says that x is years after the purchase. Okay, so that's part A. And then part B says, in how many years will the value of the building be $24,500? So I plug that in for y. So 24,500 equals 50,000 minus 2,000x. And I'm going to screw this up. I'm going to pause and do the work, saving. And so in the end, when you divide this, you get 12.75 years. Okay, so after 12.75 years, this would have a value of 24,500. Okay. Example number 2 says the x and y table shows total personal consumption expenditures in the United States in trillions of dollars for selected years, X. So we don't have every year, we just have like every 5 years or so here. They throw a number out, they do an evaluation. So we're supposed to write a linear equation for America's spending in Y in terms of X using these 2 points. So if we just kind of center in on the endpoints here, so cover these up and just look at the endpoints, what would be the linear equation? So what I'm going to do is I'm going to look above over here. I'm going to find the slope between those two and then try to find a y-intercept for those. Okay. So the slope between these guys, I want y2 minus y1. So I'm going to look at my y values. Here's a y value, here's a y value. I'm going to go 10.2 minus 3.8. Now I want to look at the x values. So 20, 10 minus 1990. Okay, now if you put those in the calculator, it's 0.32. And it's probably easiest here to use point slope form. You know, point slope, remember, is y minus y1 equals m times x minus x1. Because I have the slope and I have 2 points. It's going to be a lot easier to do it this way. So I'm going to go y minus and just pick one of the y values. Okay, so either be 3.8 or 10.2. It doesn't matter. I'll just do 3.8. Equals the slope, 0.32, times x minus, and now it has to be the x value that goes with that, so 1990. Okay. And part B, use this equation. So use this equation to estimate their expenditures in 2005. So I'm going to plug that in for the x value. So I've got y, and I'm going to actually go like this. I'm going to go 0.32, and I'm going to plug this 2005 in for x, minus 1990. I'm going to slap that negative 3.8 on the other side as positive 3.8. And then you can put it in your calculator then, and it comes out to be 8.6. Now 8.6, remember, this is in trillions. So go up here, in trillions of dollars. Okay, so trillion. Part C, use the equation in part A to do 2015. So right here, put 2015 instead. And you get 11.6 trillion. Now, superimpose a graph of the linear equation on the scatter plot. Okay, so how are we going to do that? We're going to do that on the calculator. A few things we got to do here, so I'll try to put these side by side. Hopefully you remember some of this from Algebra 2 with making some lists and that kind of stuff. So we want to make a scatter plot of the data along with the equation. So first off, I'm going to put the equation in. So I'm going to copy the equation, but I'm going to put the plus 3.8 on the end. So 0.32 x. Okay, so I'm going to type it in like that. And then to make a scatter plot, I don't know if you remember doing this or not, but you push second stat plot, and the number 1, I'm going to hit enter. And I want to choose, first off, I want to turn this on, so hit enter, and then it's for list 1, list 2, so that's good to go. Problem was I need to put my lists in also now too. So for my list, I'm going to push, if you can see this on the screen, I'm going to push stat and edit. Okay, so this is for lists. It just so happens I already have the data in there. So my x values, 1990, 1995, all the way through. And then my y values all the way through. Okay, you gotta make sure you do that. I was a step ahead of myself. So now I'm gonna go back to stat plot. Once I got everything going, so all that's turned on and good to go. Now I want to graph it. So if you hit graph, you're just gonna get the equation. It's gonna graph that equation, which isn't gonna show up on here because it's in the y-intercept. I didn't look to see the y-intercept is probably in the thousands. So we're going to do that. We're going to push zoom and then zoom stat, number 9. What that does is it kind of zooms in, gives us a perfect picture. So when anytime you're doing a scatter plot, instead of pushing graph, just go straight to zoom stat. Okay, look at that. There's the dots. And there's a line. So this is the scatter plot of the points, and that line's going through, it has a pretty good fit. So that's a very strong graph there. So there's really nothing to draw there. I mean, I'm not going to ask you to redraw this on a piece of paper, but be able to do that on your calculator. Okay. Okay, now on the back side, we're going to kind of set up the next activity. So hopefully a lot of you get done with this video about the same time, because we can do number 1 on the video, and then from there on out, we're going to actually do this as an activity together. So we are investigating the amount of time it takes to do the wave with the number of people. Which of these would be considered the independent variable? So we're going to be time and number of people. So which one, independent means it doesn't depend on the other one. So this one kind of dictates the other one. And for this one, the number of people would determine the time. So we'll start with the number of people and we time it, and the output's time. We wouldn't say 1 minute, how many people is that? We'd say 5 people, how many minutes is that? Or how many seconds, or whatever it might be. So the number of people is the independent. Which one would be the dependent? Well, time. So time to do wave. Okay, so we're going to do this in class. Once we get everybody caught up, we're going to do this in class, collect some data, and go through these steps together. So if you're Zooming, hopefully you can, if you're at home, we'll try to get everybody involved in this, or we'll at least share our data with you if you're behind. So.